Okay, so we're going to be graphing systems of linear inequalities. I tried to underline that, but didn't have the right tools. So this time we're going to be given two equations, actually inequality, and our solution, since we have greater than, less than, greater than or equal to, less than or equal to, our solutions are going to be where the shaded areas for both graphs intersect. So we're going to be doing shading again, just like we did at the end of the last chapter. But this time, since we're dealing with a system, we are looking for where the shaded areas collide. Okay, so your two steps is to graph each inequality and use either different colors or different shading techniques like, well, probably wouldn't want to use a cross, but like dots, or one region could be dots, another region could be stripes, or your stripes could go different ways, and that way you know which is which. Step 2, identify the region that contains the solutions to both inequalities, which is the region that contains either both colors or both techniques of shading, however you choose to show your solutions. Let's go over some examples. We've got y is less than or equal to 3x minus 2, and y is greater than negative x plus 4. So we're going to graph both of those inequalities. Keep in mind we're using solid or dotted lines based on your inequalities. So the first one, y is less than or equal to 3x minus 2. And plot points there, maybe. So my y-intercept is negative 2, and then my slope is 3, so up 3 over 2. Plot another point. Go down 3, up 2, plot another point. Okay. Oops. I plotted the wrong points. I don't know why I went over 2, but I should be over 1 instead. So let me change that. Up 3 over 1. There we go. Now that is going to be a solid line because my equation is less than or equal to. And then because it's less than or equal to, I'm going to shade below that line. Now I'm going to use two different colors for this. So I'm just going to go ahead and shade the whole thing in. Alright, y is greater than negative x plus 4. To graph that line, I'm going to switch colors. I'm going to put my y-intercept at 4. Down 1, right 1, up 1, left 1. My equation, or inequality, is greater than, there's no equal to, so it's going to be dotted line. And I'm looking for where it's greater than, so I'm going to shade above the line. Okay, so my solution then, I'm going to mark in black. My solution is where the two places intersect. So where my two colors intersect, so my solution is all of this area right here in black. Alright, let's do another. Alright, we've got 2x minus 1/2 y is greater than or equal to 4. I need to solve that equation for y in order to be able to graph it. So it's going to be 2x minus 1/2 y is greater than or equal to 4. And subtract 2x, so negative 1/2 y is greater than or equal to negative 2x plus 4. Multiply both sides by a negative 2 to flip to get rid of that negative 1/2. I have to flip my inequality since I multiplied by a negative 2. So that's y is less than or equal to positive 4x minus 8. So down 8. And 4x would be up 4 over 1. Alright, and it's equal to, so solid line, less than, I want to shade below. Now on this one I'm going to show you, I'm going to keep the same color ink the whole time, but I'll show you what I meant on our first set of notes where it said different techniques. I'm going to do horizontal lines right here. Alright, now second equation, 4x minus y is less than or equal to 5. I'm going to solve for y, so subtracting 4x from both sides gives me negative y is less than or equal to negative 4x plus 5. I have to change the signs. Alright, now I'm going to make that line, so down 5. And the slope is 4 again, so up 4 over 1. Oops, yeah, it's solid line. And I'm looking for where everything is greater, so I'm going to shade in. This time I'm going to shade doing vertical lines. Alright, so my solution is where the two lines intersect, or the two regions intersect, but they never intersect. So the answer is no solution. There are no places where the two solutions of those regions intersect. Alright, example 3. We are going to revisit graphing absolute value functions. But first, let's do that. Y is less than or equal to 4. So I'm going to plot my point at 4. It's a horizontal line. It's less than or equal to, so it's solid. And I'm going to shade everything below that line. Alright, now y is less than or equal to x minus 5. That is going to be my parent function with the vertex at 0, 0, shifted to the right 5. So my vertex is now going to be 5, 0. 1, 2, 3, 4, 5. There's no vertical stretch, so my slope basically is still 1 and 1, 1 and negative 1. It's greater than or equal to, so solid line. And then since it's greater than, shade in above the V. So my solution then is where those two regions intersected, which is where horizontal and vertical lines collide. My graph is not really nice looking, so I'm going to use the second color to color it in so it looks better. That nice V there. Okay, and there's my solution. Alright, let's do another example with absolute value to kind of get some practice. Alright, y is greater than or equal to 2 on the absolute value of x plus 1. So again, I have a horizontal shift. Vertex moves from 0, 0 to negative 1, 0. then, but this time I have a vertical stretch, so it's a vertical stretch of 2, so I'm going to go up 2 over 1, both to the left and to the right. It's greater than or equal to, so solid lines. And since it's greater than, I'm going to shade above. Alright, and then the next one is y is less than x plus 1. So I'm going to plot my point. I'm going to use a different color. It looks better to me. And then my slope is 1. So up 1 over 1, down 1 over 1. It's got the same point there. And then it's a dotted line. And let's see, it's less than, so I'm going to shade below. Okay, so my solution is where those two regions intersect. Now, they do intersect at this point right here, but that point is not a part of my solution for y is less than x plus 1, because it's less than, it's not less than and equal to. So my answer for this one is also no solution. Your journal assignment, what I want you to do is write the title of Systems of Inequalities and then answer these sentences. Answer using complete sentences. How do you find the solution to a system of linear inequalities? In your assignment for 3.3, pages 41 to 43 in your workbook, numbers 1 through 3 all, and then 4 through 18 even.